And while that's coming up, our most striking observation to date is the powerful effect that solar light appears to have on killing the virus, both surfaces and in the air. We've seen a similar effect with both temperature and humidity as well, where increasing the temperature and humidity, or both, is generally less favorable to the virus. So let me illustrate with this first slide. If you look to the right, you'll see that term half-life with a bunch of time stamps on there. First, let me tell you what a half-life is. We don't measure the virus as far as how long will it live on a surface. We have to measure the decay of the virus in terms of its half-life, because we don't know certain elements. We don't know how much a person expectorates when he spits, right? When he sneezes, whatever the case may be, we don't know how much a virus is in there. So that has a bearing on how long the virus is going to be alive and active. So we measure it in half-life, because half-life doesn't change. So if you look at an 18-hour half-life, what you're basically saying is that every 18 hours, the life of the virus is cut in half. So if you start with 1,000 particles of the virus, in 18 hours you're down to 500. In 18 hours after that, you're down to 250, and so on and so forth. That's important as I explain the rest of the chart. If you look at the first three lines, when you see the word surface, we're talking about non-porous surfaces, door handles, stainless steel. And if you look at as the temperature increases and as the humidity increases with no sun involved, you can see how drastically the half-life goes down on that virus. So the virus is dying at a much more rapid pace just from exposure to higher temperatures and just from exposure to humidity. If you look at the fourth line, you inject the sunlight into that, you inject UV rays into that. The same effects on line 2 at 70 to 75 degrees with 80% humidity on the surface, and look at line 4, but now you inject the sun, the half-life goes from 6 hours to 2 minutes. That's how much of an impact